Hello and welcome to the Simple Math YouTube channel. My name is Craig Sipple and I'm here to make math hopefully a little more simple for you. If you do find that this was helpful, then please feel free to like the video or leave a comment. Any feedback that you might have would be greatly appreciated. The problems that you find in this video come from an Algebra 1 test review that I created for my students. The review was created in Microsoft Word, and at your request, I would be more than happy to send it to you via email. Otherwise, I'm assuming that you are an Algebra 1 student at Pacifica High School and that you are watching this video as a part of our TAP tutoring program. So before we get started, let's first of all start with putting our name on the paper, right? So you got your name, and don't write your name, right? So put your name on there, and then for period, what I'd like you to do, because some of you are coming from different teachers, some of you are my students, but some of you are coming from a different teacher. So under period, if you would just put your teacher's name. Your teacher's name. Okay. So before we get started, I wanted to start with the idea of kind of looking at a checklist of things that we're going to do as we go throughout this test review. And again, you're watching this to go through the problems that you missed on the test the first time around, hopefully understanding it better this time, and then so then that way you can redo the test and do better this time. So what I wanted to start with is thinking about a solving equations checklist, because what we're going to do is we're going to approach every single one of these problems pretty much the same way. So there's going to be 5 different things that we're going to be looking for as we go through each one of these problems. So the first thing that we're going to look for is that we're going to look to see if there's any parentheses. So if we see parentheses, then we're going to distribute, and distribute's just a fancy math word for multiplying. Second thing is that we're going to combine like terms, right? So if we see any like numbers or like letters, then we're going to combine those things together. And I should have mentioned, by the way, I would like you to write this down in the upper left-hand corner of your page. Should have mentioned that before we started. But so if you hadn't already done so, go ahead and copy the little checklist on the top left, because we're going to keep referring back to it for each one of the problems as we go throughout this. Third thing we're looking for is we're looking to move all the variables to the same side. So we need all of our variables on the same side. Sometimes there's only one variable, but sometimes there's more than one, and sometimes they're on different sides, so we just need to get those things together. One thing that we want to keep in mind is that when we have 2 numbers that we need to get rid of to isolate the variable, that we always add or subtract first, and then we multiply or divide last. And once we actually get into solving a problem, I'll show you a little bit more as far as what we're talking about on that. Alright, so let's go ahead and take a look at this first problem. Now, the first 3 problems that are on the review, these are actually pretty easy problems, because the California State Standards says that in addition to solving equations, there's a separate standard that says you just have to be able to simplify. So it's almost kind of like someone started doing the problem and then they didn't go all the way, they didn't solve it. So what we're going to do on this one is that we actually only have to do really kind of 1 or 2 little things, and then we check down at the multiple choice to see if our answer is there. Well, so let's start with our checklist. So we got our checklist. First thing on there says distribute with parentheses. Okay, so I see parentheses, and the first thing that I'm going to do is I'm going to circle the number that's in front of the parentheses, and then I'm going to draw an arrow to where I'm putting those numbers. So I circled the number and then drew an arrow. So 4 times x would be 4x. 4 times -2 would be a -8. Remember that with multiplication and division, same signs positive, different signs negative. Now, the other number that I need to distribute there, I've got a -6. So let's go ahead and circle that. And the reason why I circle that, by the way, is that because I don't want to see that that's just a 6. No, that's actually a -6. So I need to make sure I get the sign right on that one. So then I've got -6 x minus 18, and again the signs were different there, so that would give us a negative. Now again, I don't have to solve this all the way. I'm going to make this one move, and then I'm going to check down here at the letters and see if I see anything that matches up. And one good test-taking strategy is go ahead and eliminate things as you see them. So for instance, I see 4x minus 8. So if I look at A, that says 4x minus 2. Well, I'm going to cross out the thing that makes that wrong. So I know the answer is not A. Now 4x minus 8, 4x minus 8. Oh, here's another 4x minus 2, so I know D's not the answer. And then let me look at the other part of this. So this is negative 6x minus 18. Well, that says a positive 6x. Well, we already eliminated A. Negative 6x minus 18. Okay, I'm thinking it's C. This one says a positive 6x plus 3. Well, no, that's not it. So then the answer would have to be C. All right, so what you'll do now is that you notice 3 columns on the page here. So the first column is the problem that I will do to show you how to do it. And then you'll try the middle column and the right column on your own. Now, as far as in this video, I'm only going to show you the answer for the middle and right column. So if you try it and you don't get the right answer, then you need to ask for help. So let's go ahead and take a moment. We'll pause here, and you go ahead and try number 1 in the middle and then number 1 on the right side. So pause the video, and then when you finish those problems in the middle and on the right, then go ahead and hit play, and we'll check the answers. Alright, so we're back. You should have done number 1 in the middle and number 1 on the right. So let's check number 1 in the middle. You should have got D for an answer. And for number 1 on the right side, you should have got B. So that, pretty much all 3 of those across were the same problems, just slightly different numbers. So now what you would do at this point is that if you didn't get either one of those correct, see if you can figure out on your own the mistake that you made. And if you're still having problems maybe seeing, why did I get this one wrong? Well, then go ahead and pause the video here and ask for help. Otherwise, we'll go ahead and go to the next problem. All right, so number 2 kind of looks the same as the first one. It just, if you look down at the multiple choice, there's, it doesn't say like x equals 5 or something. It's not solved all the way. All right. Well, so let's just go through our checklist. So we've got to distribute with parentheses, right? So we see some parentheses, so that's the first thing that we're going to do. So again, what I'm going to do here is I'm going to circle what I'm going to distribute, right? And because parentheses means multiplication. When you see 2 things next to each other, that means they're being multiplied. So we're going to go ahead and distribute that negative 3. And so that becomes a negative 24x. Right? Signs are different. And negative 3 times 2, which would be a negative 6. Again, the signs are different, so that would give us a negative. And then equals 15x. All right, so now I check down to the bottom. Let's see, I've got 6x, and they've got 18s and 14. So I think I'm going to have to do one more step on this one. Like I said, sometimes you have to do one step. Sometimes you have to do more than one step. So my second thing on my checklist is I want to combine like terms. Now, when we talk about combining like terms, we're talking about combining numbers with numbers or letters with letters. In this case, our variables, which are x. So we can actually combine these 2 things together. So I've got a 6x right there and a negative 24x, and then what I want to do is combine those 2 together. Now when I look at this, and when I think of combining, I think of 2 teams. I think of a positive team and a negative team. So if I look at this and I kind of think of sports, right, because at some point we've all kept score, whether it was in a game, sports, something like that. So think of this idea of that's saying that there's 6 positives and then there's 24 negatives. Well, and then I would ask myself, well, what do I have more of? Do I have more positives or do I have more negatives? Well, I have more negatives, so I know that the answer would be negative. And then I go back and ask myself, all right, well, how many more negatives do I have than positives? Okay, well, so to find the difference, I would have to subtract, right? So 24 minus 6, which would be 18. So I get a negative 18x. And then I'm just going to bring down everything else that was there. Minus 6 equals 15x. And we're going to take a look down here. See, I've got negative 18x. Well, so I know it's not the thing that says 14x. I'll cross that one out. Negative 18x minus 6. On B, they got a plus 6. Oh, no, that's not it. They got a plus 1 on C, so I know that's not it. So process of elimination, the answer would have to be A. And again, I can verify that. Alright, so go ahead and pause the video now at this point. Try number 2 in the middle. Try number 2 on the right side. And then once you've completed both of those problems, go ahead and restart the video and we'll check our answer. Alright, well, let's take a look and see what you got for number 2. So number 2 in the middle should have got A for your answer. And for number 2 on the right side, should have got D for your answer. All right. And again, if you didn't get either one of those correct, before you ask for help, see if you can go back and figure out what your own mistake was, right? Before you ask for help. But if you're still not sure, what went wrong, we'll go ahead and ask for help, right? And someone will be around to help you. All right. So let's take a look at number 3. Okay, so now number 3, it looks kind of the same thing, but you notice over here on the multiple choice, the A, B, C, D, the numbers have gotten, there's less terms there. There's an X on the one side and a number on the other. So all that just means is that we just have to do a little bit more work, but that's all right. We're tough. We can handle it. All right, so again, let's refer to our checklist. So first thing we're going to do is distribute with parentheses. So I do see parentheses, so that means that I am going to be distributing. So circle that 5 and then draw an arrow. And the reason why we draw the arrow, by the way, is that we want to catch ourselves from making this mistake right here. 5 times 3 is 15. And then for some reason, we always multiply the first number, but then for some reason, we bring down the second one without having multiplied it, right? So the idea with drawing that arrow is just to force ourselves to say, oh yeah, I gotta multiply that other one as well. So that would not be a negative 6x. Let me get out my eraser. But that would be a negative 30x. And let's see what else we have here. So we got equals 7. Now I see another set of parentheses. And then you might say, well, wait, do I distribute the 7? Do I distribute the negative 4? Well, you look at what's right in front of the parentheses. So what's right in front of the parentheses would be that negative 4. So I'm going to circle it to make sure that I catch that it's negative, and then I'm going to draw an arrow there. All right, so negative 4 times 1. Again, the signs are different. So I know that it's going to be a negative. And then negative 4 times negative 4x would be a positive 16x. So remember, when you multiply or divide, same signs positive, different signs negative. So they were the same, so that would be a positive 16x. All right, well, I've got still some more work to do. So let's go to the second thing on our checklist over here, which is to combine like terms. All right. So what I'm looking at is on the left side, I see 15 and negative 30x. Well, those aren't the same because 15 is a number and negative 30x is a variable. Let me go to this other side. Oh, okay, 7 minus 4. Those are both numbers, so I can combine them together. So if I took 7 and negative 4 and I combined those two together, well, so 7 minus 4, that's easy enough, right? 7 minus 4 is 3. But if you wanted to think of it in terms of the positives, right, there's more positives than there are negatives. So the answer would be positive, and then there's 3 more positives than there are negatives. Now, what I like to do is that I like to treat solving equations almost like a game where I can only make one move per turn. So I make my one move, and then I bring everything else down. So you notice that I didn't jump to trying to combine 2 steps into one. Not that you couldn't do that, but we want to try to make sure that we set ourselves up where we're not going to make any mistakes. Because see, if we try to start doing too much mentally, then that's where we can make some mistakes. All right, let's look at number 3 on the checklist over there. So we've got move all variables to the same side. Now, what are they talking about, same side? Well, if you see what's happening here, there's your equal sign. And you kind of think of the equal sign as what divides the two sides of the equation. So this is the left side over here, and then this is the right side over here. Well, so you have x's on 2 different sides, so we need to get them together on the same side. Now, what I cannot do is I cannot do this, right? I can't say, oh, I'm just going to combine those. Well, no, they're not on the same side, so I can't do that. Let's back that out, right? Now, what I can do, though, is that, again, think of this almost as a wall, a barrier kind of dividing the two sides. So what I need to do is pick one up and move it over to the other side. Right? And it doesn't matter which one you move. You can move negative 30 over with 16, or you can move 16 over negative 30. So it actually really doesn't matter which way you move it. So I don't know. Let's Let's add 30 to both sides, right? And by the way, how we move things is that we do the opposite, right? So because we don't want 30x to be on the left side anymore, so the way to get rid of him is to add 30x. Because see, negative 30 and a positive 30 would cancel each other out. Well, we have this kind of golden rule of algebra which says what you do to one side, you do to the other side. So we've added 30x to the left side. Now we've added 30x to the right side. The other thing I like about drawing this line in the middle is that we can clearly see, okay, I've done 30x on the left, and then there's 30x on the right. And now negative 30 plus 30 would be 0. You don't have to write 0. We just kind of slash it out like that, right? And just kind of do a little slash like that. And so that was our move for that turn. So let's bring everything else down. And then I've got 16 x's and 30 more x's. So if I put all that together, that would give me a total of 46x. Oh, okay, 46x. I'm starting to see that. Maybe it's A, maybe it's D. So let's go a little further with it. All right, now, so what's next on the checklist? Add or subtract. So we need to see, okay, what number is on the same side as x? So if we wanted to isolate the variable to get x by himself, well, there's two numbers that are on the same side as him. There's a 3, and then there's a 46. Because see, 15's on the other side, right? So again, think of this wall kind of split in the two sides. So we don't care about what's going on with 15. We're just trying to get rid of the 3, and we're trying to get rid of the 46. Well, so we add or subtract first, right? Because that says 46 times x. So that would be dividing to get rid of the 46. So we have to add 3 first. Well, rather, we have a positive 3, so we would have to subtract 3. So let me go ahead and subtract 3 from both sides. And again, why are we subtracting 3? Well, because we're trying to get rid of that number. We're trying to eliminate it. So what we do is to undo addition, the opposite operation would be subtraction. And again, what we do to one side, we do to the other. So 15 minus 3 would be 12 equals 46x. All right, so I know the answer is not going to be C because, well, it's not 10x. Not that. Now, they've got 46 equals 12, 46x equals 18. See, why does mine look different? Oh, it's just backwards, right? So mine's just backwards. That's all it is. So if I just flipped it around, 46x equals 12, then it looks exactly like what they have, right? So the correct answer there would be A. All right, so same deal. Take a second, pause the video here, and try number 3 in the middle, and then try number 3 on the right side. All right, well, hopefully you didn't have too many problems with 3 in the middle and 3 on the right. So let's go ahead and check your answers. Make sure you got the right thing. So for number 3 in the middle, should have got C, 29x equals 5. And for number 3 on the right column, again, should have got C, 21x equals 9. All right, and again, if you did not get those two answers, go ahead and pause now. Let's make sure you understand what happened in the middle and on that right problem. So it's only if you got both of those correct that we then now move on to the next problem. All right, so let's take a look at number 4. Oh, words. I know we're all freaked out about word problems. But I want to show you that this really isn't, I mean, it's a word problem, but I mean, you see that there's an equation there. P equals 820 plus 10h. So hopefully, I don't know, maybe it's not going to be as scary as what we might think. So let's see what it says. It says the total paycheck P, so they're saying that P stands for paycheck, right? Because in math what we do is we use variables, we use letters in the alphabet to represent unknown numbers, or what we would say unknown quantities. So, you know, you could use any letter. I know we use X and Y a lot and that sort of thing. But, you know, in the context of a word problem, you can use a letter that matches up with what it is you're talking about. So if we're talking about a paycheck, then sure, let's use P. That makes sense. All right, so a paycheck that Raul earns in a week if he works H hours. All right, so there's another thing. So we got H hours of overtime is given by the equation. And then they give us an equation. If Raul earned $900 last week, how many overtime hours did he work? So the idea here is he's got a base pay, and then if he works overtime, then he gets an additional amount of money. Well, so they give us this $900 here. I'm sure that's probably important. right? So let me put a box around that. And then it says how many hours. So if it's saying how many hours, then what they're wanting us to do, so if it says how many hours, what they're wanting us to do is they're wanting us to solve for h. If they're saying how many hours, well, so this $900, you know, so I'm either going to plug it in for P or I'm going to plug it in for H. Well, but I'm solving for H. That's actually what I'm looking for. And besides, H is hours. It's time. It's not dollars, right? So the thing that represents money in this problem is the P, which is his paycheck. So what I'm going to do is I'm going to substitute, right? That word substitute just means to replace. I'm going to replace the letter P with $900. And then I'm just going to copy everything else that's there. 820 plus 10h. All right, so let's solve it. Let's check our checklist real quick. And, you know, it's a checklist because maybe sometimes we have to do something on the list. Maybe we can skip it. So first thing on the list, distribute with parentheses. Well, I don't see any parentheses, so there's no distributing we have to worry about. Let's move on to the next one. Combine like terms. Well, you know, there's an 820 and a 900, but they're on different sides of the equation. Let me kind of draw my little wall there. So they're on different sides, so I can't combine those two guys. And then h is a variable, 820 is a number, so I can't combine them either. All right. Now, so we're going to add or subtract first. And so what we want to do is we see h, and we say, okay, we want to isolate just to get by itself. So we want to get h by itself, and there's two things we got to get rid of. There's an 820 that we need to get rid of, and then there's a 10 that we need to get rid of before h can be by himself. Again, 900 is on the other side. We don't care about what 900 is doing over there. Well, the next thing on our checklist says to add or subtract first. So this says a positive 820. And how we, again, get rid of things is we do the opposite. So the opposite of a positive 820 would be a negative 820. And I would subtract that from both sides. Again, we'll slash that out. And 900 minus 820, which would be 80. Right, because 0 minus 0 is 0. And, you know, if you had to, there's nothing wrong with doing a little scratch work right here, right? So you'd have to, you can't take 2 away from 0, so you got to borrow. That would become an 8. The 0 would become a 10, right? So 10 minus 2 would be 80. 8 minus 8 would be 0. Now, you know, hopefully you were able to do that calculation mentally. I just wanted to show you that if, you know, sometimes the numbers get a little bit larger, and you know, this isn't mental math class, so I don't expect you to do everything mentally. So just do a little scratch work. There's nothing wrong with that. All right, now let's bring down the rest of what's there, equals 10h. Now, what we want to do is we now want to get rid of the 10. And then you look at it and say, okay, well, what's going on between 10 and h? Well, they're being multiplied. And you might say, well, I don't know. How do you know they're being multiplied? Well, multiplication is kind of a funny operation. It's actually the only operation that routinely is shown without a symbol. What I mean by that is that if they wanted to say 10 plus h, they would say 10 plus h, right, with a plus sign. If they wanted to say 10 minus h, well, there would be a minus sign there. If they want to say 10 divided by h, well, there would be a bar, right, because that bar means division. So multiplication's the one weird one that's out here all by himself, which is there's no real symbol. The two things are just written next to each other. So now if you kind of maybe tend to forget that, there's nothing wrong with putting a little dot right there to remind yourself that that means multiplication. Oh, okay, so then the opposite operation, how we undo multiplication, is we divide. I use that word undo, by the way, because I almost kind of get a visual of, let's say, a knot, a string, some yarn that's all knotted up, and we're trying to untie this. And so what we're doing is we're doing the opposite of things to get h by itself. We're trying to untie this knot. So the opposite of multiplication is division. And again, we got our golden rule. What you do to one, you do to the other. So we divide by 10. And then the 10s cancel each other out. And then 80 divided by 10, well, that would be 8. And so we get 8 equals h. It wouldn't be wrong if you left your answer like this. You know, formally what we do is we would rewrite that as h equals 8. But either way, you'd have the same answer on that one. All right, so there's two problems for you. Number 4 in the middle, number 4 on the right side, so give that a try. Go ahead and pause the video now, and we'll check back with you in a second. All right, well, we're back. Hopefully we were able to convince you that maybe word problems, or at least not this word problem. I mean, definitely there's some word problems that might seem a little scarier. But this word problem, they actually gave us the equation. So, you know, in that way, I don't think that it was as difficult. All right, let's see what you got with number 4 in the middle. So for number 4 in the middle, what you should have got is h equals 9. And for number 4 on the right side, story about someone's cell phone bill, should have got m is equal to 10. M is equal to 10. All right, so those are the first 4 problems on the front side. So if you go and turn your worksheet over to the back side, we'll look at problems 5 through 9 on this one. Whoa, yeah, you know, you flip it over and you look at that, and I mean, there's a couple of things that are probably freaking you out. You've seen the fraction there, and then it looks like this, you know, big long equation that looks real scary. Well, that's all right. You see my little guy over there in the corner, the guy with the broom there. The reason why I think of the guy with the broom is that he's just gonna come along and he's just gonna sweep some stuff up, right? So once we kind of do a little sweeping here, we do a little sweeping here. Oh, he disappeared. Oh, there's his head. We just need to do a little cleaning up here, right? So once we can clean some stuff up, then it won't be as scary as it might look right now. So let's just go down the checklist, right? So it's been the same thing that we've done to approach each one of these problems. So the first thing we want to do is we want to distribute if we see those parentheses, which we do. And actually we see 2 sets of parentheses, right? So there's one set there, and then there's one set there. So we've said all along that you take the number that's in front of the parentheses and you distribute, right? And again, distribute just means to multiply. I'm circling the number that I'm going to distribute, which in this case is 1/2, and then drawing an arrow to the 2 numbers that I'm being multiplied there. And then you're like, you know, I've never been good with fractions. I'm not sure about all this. Well, all that means is that if you're multiplying by 1/2, all you're doing is really taking half of that. Let's maybe make a little note over here to the side. So all we're going to do is we're just going to take half of 6y and half of -4. That's all that means, right? So if I said, what's half of 6y, you're like, oh, okay, well, half of 6 is 3, so that would be 3y. What's half of -4? Well, half of 4 is 2. And then there you go. That wasn't too bad. Let's check out the other number that we have to distribute here. We've got a -5 that we've got to distribute. So let's go ahead and draw that out. And so we get -5y minus 10. And again, remember, multiplication, same signs positive, different signs negative. You'll hear me say it maybe not a million times on this video, but if you watch a couple of others, we'll hear that quite a few times. Same signs positive, different signs negative. But again, that's only when you multiply and divide. And let's copy everything else down here so we get equals 8. All right, so let's check the checklist. So we distributed. Next thing we need to do is combine like terms. So again, what we're looking for is are there any numbers or are there any letters that are the same that we can combine and that are on the same side? Well, you see 8 over there, he's all by himself, so there's nothing 8 can be combined with because he's the only thing that's even over there. So let's look at the left side. All right, so I see a y here and I see a y there, so I'm thinking I'm going to be able to combine those two things. So I'm going to take this 3y and I'm going to take this -5y and I'm going to combine those two things together. Now how I would read this is I would look at that and say, okay, that's a +3, because again, you know, when you don't see a symbol in front of it, then we assume that it means that is positive, so that would be a +3. And then I look over here and I would interpret that as a -5. And then again, so I go back to my idea of 2 people playing a game, the positive team and the negative team. Who scored more points? Well, the negative scored more points, right? Because the negative scored 5 points, the positives only scored 3. So I know that my answer would be negative, and then I say, okay, well, how many did they beat the other team by? Well, they scored 5, they scored 3, so that means they being the negatives, won by 2. And as I mentioned earlier, treat this as a game where you make one move per turn. So we just made our one move, so let's copy everything else down. And we're still checking for like terms, right? So just because we combined one thing doesn't mean there isn't something else to combine. Now, I'm seeing a -2 and a -10 that we can combine. So let's combine those two, right? So I got a -2 and I got a -10. Now, in terms of the whole game, positive, negatives, that sort of thing, as is true in sports in real life, sometimes it's a shutout. Sometimes one team scores all the points. So if you look at this, for instance, this says the negative score 2 points, and then the negative score 10 points. Well, if I wrote this wouldn't make any sense to say a positive 12. How could I say that the positives scored 12 when they didn't even score anything, right? That doesn't make any sense. So if I thought about it and I said, okay, if the negatives score 2 and then they score 10 more, right? Or maybe another way to think of it is if I had 2 negatives and 10 more negatives, now I have a total of 12 negatives. But I know you're thinking like, oh, I thought a negative makes a positive. Well, again, that's only with multiplication and division, and that's where a lot of people make a mistake because they confuse those two things. But so instead of maybe necessarily relying on rules, I'd like you to think of it maybe a little more conceptually or visually, again, thinking about two teams scoring points. Well, there's 2 of them, and there's 10 more of them, so now there's a total of 12 of them, and they're negatives. All right, and so let's bring down the equals 8. And let's see, let's check the checklist. Move all variables to the same side. Well, I only see one variable. I just see a y right there. I don't see any other variables, so nothing else I think I got to do there. Now, let's kind of draw that wall again. See, we used green last time. We'll stick with the same color. So there's our little wall, and as we mentioned it from the very beginning of the problem, 8's over here by himself, so who cares? Nobody cares what 8's doing over there. We're just trying to get y by himself, right? We're trying to isolate that variable. So there's 2 numbers that I need to get rid of. There's a -2 that I need to get rid of, and there's a -12 that I need to get rid of. Well, as we just talked about in the last problem, 2 numbers next to each other mean multiplication, and I know that the opposite operation from multiplication is division, which is what I do last. So what I do next is I add or subtract. So I'm going to add or subtract first, right? Because that says -12, and so the way to get rid of that would be to add 12. So let's add 12 to both sides. So I'm going to do a +12 and a +12. And again, you don't have to draw that line down the middle. I just like it because it helps me separate the two sides of the equation. And also, when I say what I do to one side, I do to the other, because that line is there, I can now clearly see, oh yeah, I added 12 to the left, and then I would add 12 to the right. What I wouldn't want to do, and what I'm trying to prevent there, is doing something like this. Well, no, I already added 12 to the left side one time. I can't add 12 to the same side twice. That doesn't make any sense. So that's the mistake that we're trying to prevent there. All right, so let's slash out -12. He's gone. Oh, and we hit him with the eraser, which I guess we could do that too. But, yeah, let's get him with that. There we go. And let's bring everything else down. So we got -2y equals 20. Now, last thing on the checklist is multiply or divide. Multiply or divide last. All right, so that says -2 times y. And again, if you wanted to, you can squeeze in a little dot there to remind yourself that means multiplication. And then the opposite of multiplication, well, it's to divide. So we need to divide both sides by -2. So let's do that. So I'm going to divide. Now let me make a mistake. And sometimes what I like to do, by the way, is I'll make a mistake that I think is a common mistake that I see, almost kind of anticipating or guessing a mistake you might make as you're following along with this. Because see, you might think, well, hey, why not divide by 2? Because isn't the opposite of a -2 a +2? Right? Because you think about that, because look at what we did above. You know, the opposite of -12 was a +12. Well, but you have to look at the operation. That says -12, so the opposite of subtraction is addition. What you have going on here is multiplication, so the opposite of multiplication is division. So you actually have to divide by the number you're trying to get rid of. And let's say, for instance, you left it this way. -2 divided by 2 would be a -1y. Not 20, 10. And if we ask the question, okay, well, how about now? Is y by itself? Well, no, y is not by itself. There's still a -1 out front. Now, we could, again, divide by -1 on both sides and get y by itself, but that would be doing too much work. So, yeah, when you multiply or divide, you're doing it exactly by the number that you're trying to get rid of. So if we're trying to get rid of a -2, we're going to divide by -2. And so with that, right, we can cancel out those two things. And so 20 divided by -2, which would give us a -10. Again, the signs are different, so we know that that would be a negative. All right, well, once again, it's your turn. So go ahead and pause the video now. Try number 5 in the middle. Once you get that one, try number 5 on the right side. Once you feel like you have the answers for those two problems, go ahead and hit play again, and we'll check your answers. So we'll see you in a second. All right, well, let's see how you did. For number 5 in the middle, should have come up with y equals -12. And for number 5 on the right side, should have came up with y equals -8. And again, if you did not get the answer, or the correct answer, to either one of those, then pause the video now, ask for some help. We'll get you some help, and then we can all move on. Otherwise, if you got them right, you're trucking along, so let's go along to the next problem. So let's look at number 6. So we have x plus 8 equals -4x minus 2. Now, this almost looks easier because it seems like there's less stuff going on. You know, that last problem, there was parentheses and fractions and all of this stuff. Right, so this almost seems a little bit easier because there seems like there's less numbers and variables. Okay, well, let's check it out. So, checking the checklist, distribute if we've got some parentheses. Well, as I look at that, I don't see any parentheses, so nothing to distribute. Combine like terms, well, let's check it out. So if I kind of split my equation into, you know, the two different sides there. If I look at the left side, x plus 8, well, those aren't like terms. -4x minus 2, those are not, right? Because -2 is a number, -4x is a variable, so I can't combine those. All right, so we can check that off the list. Move all variables to the same side. All right, so I think this is actually where we're going to have to do something, because you see, -4x is on the right side, and then that +1x is on the left side. And again, what I cannot do, don't write this down, what I cannot do is do this. I can't say, oh, that would be a -3x. Right? That's the idea with drawing that line, is hopefully you see, like, oh yeah, that's the fence, it's the barrier, it's the wall, right? So that separates the two sides. So I cannot do that. So let's back that up, right? Because they're not on the same side. That was on the previous step, combine like terms, if they were on the same side, but they're not. All right, so we've got to move all the variables to the same side. We said earlier, it doesn't matter. You know, you could pick up -4 and move them over here with the +1, x, or you can move them, take this x and move it over there. It doesn't really matter. You know, when we write our final answer, and this is just kind of personal preference for me, you know, when we write our final answer, our final answer is always x equals, and then, you know, whatever the number is. So we write it with a variable on the left. So if you wanted to treat it that way, you could. So let's move that -4x. And again, how we move things in algebra is we do the opposite. So the opposite of a -4x would be a +4x. And again, our golden rule, once again, what you do to one, you do to the other. Right? And the reason why we're doing the opposite, by the way, is because we don't want x to be on the right side anymore. So how we get rid of that is, again, that we do the opposite of that. So the -4 and +4 cancel each other out. Again, you don't need to write 0. That just kind of clutters things up. So just put a slash through it to indicate that it's not there anymore. All right, so here's another thing. Now, how many x's is that? That's really 1x. You might want to write that 1 in there to remind yourself, oh yeah, that really is 1x. So if I had 1x and then 4 more x's, well, now I have a total of 5 x's. Made my move, bring it down, and equals -2. All right, so I can check one more thing off the checklist. Got everybody on the same side. Now I'm looking to add or subtract, right? So if I look at it, if I'm trying to get x by himself, I see two numbers I got to get rid of. I see a 5 and an 8. Again, nobody cares what -2 is doing. He's on the other side. So we always add or subtract first. So I see that +8. So opposite of that +8 is going to be -8. And we do that to both sides. Again, the 8's cancel each other out. This says I have 2 negatives and then 8 more negatives. So again, sometimes there's a shutout. Sometimes one team scores all the points. So if I had 2 negatives and then 8 more negatives, now I have a total of 10 negatives. Right? A total of 10 negatives. I think I wanted to do that in yellow. Alright, and let's bring everything else down. You got 5x equals negative 10. Alright, so we can check off add or subtract, and the last thing on the list is to multiply or divide. Again, that says 5 times x. As we mentioned, you put a little dot in there if you want. So the opposite of multiplication is division. So we will divide both sides by 5 so that those cancel each other out. What we do to one, we do to the other. And negative 10 divided by 5. So the answer is a negative 2. But is it a negative 2 because the 10 is bigger? Right? Because some of you might be thinking that. You might say, oh, okay, well, there's more negatives, so then that means it's going to be a negative 2. Well, no, when you add or subtract, that's when we say, what do you have more of? So the answer is negative, true. But it's not negative because the 10 is negative and it's bigger. It's negative because the signs are different, right? So make sure you don't confuse those two things. So we end up getting x equals negative 2. All right, so once again, go ahead and pause the video here. Try number 6 in the middle. Try number 6 on the right. I think you'll do well. You're feeling good. I'm feeling good. So go ahead and pause it now, and let's see what you come up with. Welcome back. So let's take a look at number 6 in the middle. So for number 6 in the middle, should have come up with x equals negative 3. And for number 6 on the right side, should have come up with x equals negative 4. Again, if you didn't get either one of those answers, go ahead and pause now. Make sure you understand what mistake you made, what went wrong. Otherwise, we'll go ahead and move on to the next problem. Uh-oh, more words again. Uh-oh, what are we going to do here? There's some animals. Well, all right, so it says a pet store has a total of 40 dogs, cats, and rabbits. The number of rabbits is 2 more than the number of dogs, and there are 6 fewer rabbits than cats. How many cats are there in the pet store? Ugh. So, you know, a problem like this is like the stereotypical algebra word problem, you know, that everyone talks about, like, oh, I hate it, or, you know, you got trains going different directions and all this other sort of stuff. Well, you know, we're going to kind of break it down, and that's why I threw some pictures on there. Now, I understand on your worksheet you don't have these pictures, but you know, I'd encourage you to, you know, draw those pictures in, because what we're trying to do is we're trying to convert from what I call English into Mathlish. And what I mean by English, well, this isn't English, right? Because it's words and it's in a sentence and there's punctuation. So, but what I want to do is I want to convert or translate into Mathlish, right? Mathlish is a way of communicating the same idea, but just without communicating with words. What I mean by that, for instance, and I'll just kind of take a little sidestep here just for a second, is that this is in Mathlish. 2 plus 2, I'm sorry, in English, 2 plus 2 equals 4. Right, that's in English because there's words, there's a period, right? Subject, verb, all that sort of stuff. But how do I write that in Mathlish? Well, in Mathlish, that would be 2 plus 2 equals 4. So that's what I mean about the difference between English and Mathlish. English, and it's not just English. I mean, it could be Spanish, Russian, Italian. You know, the spoken word, right? Language, as far as what we're used to. And math really is kind of a foreign language, and you probably feel that way. But math really is kind of a foreign language, and so it's a way of communicating the same thing, but just not needing to use words. You know, you probably have often heard that math is a universal language. Well, one of the reasons why we say that is that someone from another country may not speak this, 2 plus 2 equals 4, right? They may not know what that says, but they know what that says, right? So it's a way for us to communicate across different languages. All right, so anyway, so that's my just a little spiel on English and Mathlish, and that's something that I'll bring up, or you'll hear again, because that's something I like to, it's how I like to kind of frame looking at what we're doing with this. All right, well, let's get this out of the way. Let's talk about some pets. So I don't know. I'm going to get out my highlighter, start highlighting some stuff. It says there's a total of 40 dogs, cats, and rabbits. Well, not just total of 40 dogs. I don't like the way I highlighted that. But there's a total of 40. Right? So there's a total of 40 dogs, cats, and rabbits. And then it says the number of rabbits is 2 more than the number of dogs. Alright, so number of rabbits, let me highlight that. Number of rabbits is 2 more than the number of dogs. And I know your anxiety is probably high. You're looking at this and you think, oh, I hate word problems. So like I said, we're just going to go through this slowly. So hopefully you're highlighting with me, and we're just going to kind of take this real slow. Number of rabbits is 2 more than the number of dogs. Okay, so it's saying, and I'm going to, this is the process of beginning to translate from English into Mathlish. So it says there's 2 more rabbits than dogs. So what I can say there is, well, there's 2 more than dogs. Okay. Now I don't know how many dogs there are, but how many of our dogs there are, there's 2 more rabbits. Well, wait, how many dogs? We don't know how many dogs. So we actually don't know how many dogs there are. We actually don't know the number of dogs. I'll just do number of dogs. Okay, well, what do we do when we don't know something? Well, in math, right, part of translating from English to Mathlish, what we do in Mathlish is if you don't know what something is, then we give it a variable. Now, again, you could use any letter in the alphabet you wanted to, but what do you think we might use for dog? Well, let's use the letter D. So we'll do D for dog. And again, that represents the number of dogs. I don't know how many yet, but we'll just put that there for now. So let's go back to the rabbit then. It says there's 2 more rabbits than there are dogs. Well, we don't know the number of dogs, but we said that it was D, and then so if there's 2 more, well then that would be plus 2, right? Because it's the number of dogs plus 2 since there's 2 more. Alright, and let's check out the cat down there. So the last thing that this thing says, so we're making some progress here. So the last thing this says is that there's 6 fewer rabbits than cats. 6 fewer rabbits than cats. Well, maybe another way to think of that is that if there's 6 fewer rabbits than cats, that means that there's 6 more cats than rabbits. And the reason why I'm thinking of it that way is that because in this other one, when we were talking about the number of rabbits, we were saying there was 2 more than dogs, and so we're already talking about comparing them as far as which one has more. So there's 6 more cats than rabbits. Well, we don't know how many rabbits there are, but we do know that there's D plus 2 rabbits, right? Because whatever the dogs are plus 2, and then if we're saying if there's 6 more than that, then that means that would be plus 6. Right, because there's 6 more rabbits. All right, so I think we're starting to shape up here a little bit. Now let's go back to that number from the very beginning. It said a total of 40. So what we're saying is that if you took the number of dogs plus the number of rabbits plus the number of cats, and if you added all of those things together, that it would give you 40. Okay. All right, now I know on my screen here I've got it all spread out, so let's see if we can kind of condense this. And we don't have our little guy with the broom on this page, but that's what he'd be doing. He'd be coming on and just sweeping everything together, kind of cleaning everything up. So let's combine our like terms. We don't have our checklist up here, but let's just kind of mentally go through our checklist. I don't see any parentheses, so I don't need to worry about distributing. I do see some like terms, so I need to get those together. So let me get those things together. So I've got a D, and a D. Well, if I had one D and another D and another D, that means I have a total of 3 Ds. And let's take a look at what numbers I have. So it looks like I've got a 2, and I've got a 6. Now, not 40, right? Because 40 is on the other side of the equal sign. So I can't say that I'm going to combine 40. Maybe we'll draw our little wall here, right? So 40 is on the other side, so I can't combine him. I can only combine the 2, and the 6. Well, 2 plus 2 is 4. 4 plus 6 is 10. So let's write that. And fairly quickly, we're down to just a two-step equation. We call it a two-step equation because there's only two numbers that I have to get rid of, or there's only two things that I have to do. So I know it kind of started off as this crazy problem at first, but now we're just down to a two-step equation. Remember the next thing on our checklist, that we're always going to add or subtract first before we multiply or divide. So let's go ahead and do that now. We want to get rid of that plus 10 by subtracting 10, right? Because we're always doing the opposite. 10s cancel each other out, and then what we're left with there is 3d equals 30. And then the last thing on our checklist was that we multiply or divide. Now again, that says 3 times d, so the opposite of multiplication, the opposite operation, how we undo it, would be to divide. So we're going to divide both sides by 3. All right, now we might be thinking, yay, we got the answer. Well, this is where these people, they make these problems, they're tricky. Because if you go back, and we maybe should have identified this from the very beginning, but the question says, how many, let me circle it here. What's happening to my pen? So the question says, how many cats? How many cats? Sorry, I had to switch pens there. I guess my pen ran out of ink. All right, so let me circle that. That was a joke, by the way, right? No, maybe you didn't get that. All right, so how many cats? Well, so what that means then is I'm actually going to solve for C, right? Or I'm sorry, not C, but we're going to solve for cats. Right, so because remember what D stands for. D stands for dog. We're not looking for how many dogs. We're actually trying to solve for how many cats. So what I would do with that is I would take this 10, right, because we're saying there's 10 dogs, and I'm going to substitute that in right there. Again, substitute just means to replace. So I'm going to put in a 10, and then I'm just going to write the rest of what's there, right? So plus 2 and then plus 6. Well, so if you added those two together, 10 plus 2 is 12, 12 plus 6, which would be 18. So the number of cats is equal to 18. Now again, these people are tricky because I guarantee you multiple choice out of A, B, C, D, 10 would be one of the answers because they're hoping that you get there and you say, oh yeah, I got my answer. Well, no, they're not asking for the number of dogs, they're asking for the number of cats. By the way, this is a tough problem, you know, so if you're kind of looking at this and you're like, oh, I don't know. This is a tough problem. So, you know, this is, I think, a really rigorous, it's a very difficult problem because we're having to translate from words into an equation, and you've got a lot going on there as far as multiple steps. All right. Don't be discouraged. I just want you to try number 7 in the middle and 7 on the right side and see what you can come up with. And again, it's really follow kind of the same format of this one. 7 in the middle and 7 on the right are pretty much the same problem as this, just some slightly different numbers. All right, so go ahead and pause the video now and try number 7 in the middle and number 7 on the right. All right, well, welcome back. So let's try and see what you ended up with number 7. So number 7 in the middle should have ended up with that there was 16 cats. There was 3 dogs, and then so that meant that there was a total of 16 cats. And then number 7 on the right side should have got that there were 13 cats because there were 5 dogs and 13 cats. Whew. All right, well, we had to kind of sweat a little bit on that one. So let's go on to this last 2. So we only got 2 problems left here. All right, so number 8, and there's a guy with the broom. He's back. And again, all he's trying to do is when we first look at this, we might be a little intimidated because it looks like there's a lot going on. But as soon as we just, like I said, just got to clean it up. We've got to get our guy. He's just going to sweep it up, and then it's not going to be too bad. Right. All right, so let's check the checklist as we've done. So right, and the checklist has been the same. You know, for every single one of these problems, we were kind of thinking of each one of these things in the same way. So distribute if you got some parentheses. See if we have some parentheses. Yep, we got some parentheses right here. All right, so that means that we're going to have to distribute. Again, what I like to do is I like to circle the number that I'm distributing, and then because I'm really trying to force myself to realize, okay, I'm multiplying, and I'm multiplying both of those numbers right there. Well, so 5 times 4z, which would be 20z, and then 5 times negative 2, which would be negative 10, and then I'm just going to copy everything else that's there. Negative 2z equals 4z plus 18. By the way, you notice on the negative 2z, with the z's, I put a little slash through the middle there because, sometimes it's kind of hard for us to read our own handwriting, and that could really easily look like a negative 22, for instance. So what I do with all my z's, I put a little slash through there so I don't make that mistake. All right, let's see if we can combine some like terms. Right, that's next on the checklist. Let's combine some like terms. Well, and again, though, when you check for like terms, I think it's good to, again, not that you have to do that, but, put that little wall there that separates the two sides. So it helps me see that on the right side, well, those aren't like terms, because that's a z and that's a number. Well, I can't do that. Let's look over here. Okay, I've got some z's and I've got some z's. So that tells me that those are two things I can combine. I've got 20z and I've got negative 2z. Again, thinking about those positives and negatives, and really kind of split the decision into kind of two different things. So first of all, just decide if it's going to be, if you have more positives or negatives. There's 20 positives, 2 negatives, so there's more positives. Then you ask yourself, okay, well, how many did they beat them by, right? How many more positives do you have than negatives? Well, you've got 18 more positives than you do negatives. So that would be an 18z. So again, we're just making one move per turn, copying everything else down. Got our equals, we got 4z plus 18. All right, looking next on the checklist, I'm going to move all the variables to the same side. So, and I left my wall a little short here. I can kind of continue that down a little further. So I see that 18z is on the left and 4z is on the right. So these two guys are not on the same side. So I cannot just combine them. I can't do what I did to 20z and negative 2z. They were on the same side, but 18z and 4z are not. So what I have to do is I have to move them all over to one side. Again, as we've said, you can move 18, you could pick him up and move him over there with the 4z, or you can pick up 4z and move him over there with that one. Just a personal preference of mine, I usually like to move things over to the left, but again, doesn't make a difference. How do we move stuff? Well, we move things by doing the opposite. That's a positive 4z, so the opposite would be a minus 4z. So let's subtract 4z from both sides. Those cancel each other out. Well, 18 minus 4, there's more positives, and there's 14 more positives. So that would be a 14z minus 10 equals 18. All right, as we've said all along, we add or subtract first, right? When you got two numbers that you're trying to get rid of, see, we're trying to get z, poor little z right here, he just wants to be by himself, just a little private time. And then he's got this 14 over here with him, and he's got this negative 10. Again, nobody cares about 18 because 18's on the other side. So that says 14 times z. So we know that how we get rid of multiplication is we divide. And then that says minus 10, which we know that how we get rid of subtraction is we add. And we know that we add or subtract first. So let's go ahead and do that addition. Right, because the idea that, and again, thinking of this idea of the opposite, because what we're trying to do is that we want this to go away. So you think about, how do I make a negative 10 go away? Well, if I added a negative 10 and a positive 10, those things would cancel each other out, and therefore it disappears, right? It goes away, which is what we wanted to happen. 14z equals 28. Again, that says 14 times z, so let's go ahead and divide both sides. So we'll divide by 14. Divide by 14, there's our golden rule. And let me slash out those 14s. And we end up with z equals 2. Z equals 2. All right, well, it's that time again for you to try number 8 in the middle and number 8 on the right side. So pause the video now, and we'll see you in a second. All right, well, let's check your answers for 8. And before we move on, I feel bad here. Forgot to get my last check, right, in that little check box. So We don't want him to feel left out. All right, so we got that there. All right, let's check number 8 in the middle. So what you should have got for number 8 in the middle, should have got z equals -4. And for number 8 on the right side, should have got z equals -1. So again, if you did not get either one of those correct, try to go back and figure out what happened. If you need some help, ask for some help, but do not go on until you have both of those correct. And by the way, and we should have mentioned this earlier on, make sure you're showing all your work, right? So don't just don't just write the problem, write the answer. We want to make sure we're showing all of our work. So in the way that I'm showing my work, as far as what I'm adding or subtracting, multiplying or dividing, we want to see all that stuff. All right, so let's look at number 9. Yay, we're almost there. So last problem here. Now this one looks a little bit different. There's some bars, right? What are these lines, right? Those aren't parentheses, right? Because parentheses have a little curve to them. What that is what we call the absolute value. And what that bar means is that the absolute value is the distance a number is from 0 on the number line. So absolute value is the distance. Maybe we'll write this down. So absolute value what that is, it's the distance a number is from 0 on the number line. So for instance, what that means, and we'll kind of look at, I've got a little example above, right? So before we actually get into solving this problem over here, let's just make sure we remember and recall just the idea of absolute value. So we'll kind of take a time out on 2x plus 4 equals 16. We'll take a time out on that for a second, and let's just look over here. All right, so you see these bars, right? You see the absolute value of -3. What that's saying is how far is -3 from 0? Well, it's 1, 2, 3. What this is saying is how far is 4 from 0? Well, you're like, duh, it's 1, 2, 3, 4. Well, you notice that the number, and for a lot of students, they remember, because you've seen absolute values since middle school. So this is not something that's new. You've seen this thing with the bars before. But what a lot of students remember is they remember, oh, okay, well, it just always comes out positive. But they don't necessarily remember or know why or understand why it always comes out positive. Well, the reason why is because distance is always a positive number. So you don't live -5 miles away from your school. It's not possible for you to drive a -70 miles an hour. Now, I know what you're thinking, and what if I go in reverse? Well, even if you put it in reverse, though, we still measure your speed and your distance in terms of a positive number. So distance is never a negative number. So that's what it's really saying. Is it's saying it doesn't matter if you're coming from the positive side of the number line, right, which is the right side over here. Doesn't matter if you're coming from the positive side or if you're coming from the negative side, which is the left side of the number line. Doesn't matter which way you're coming at it. Either way, the distance, how we measure it, is going to be a positive number. Okay. Now, what if we look at something a little bit different, right? So what if this says, what if there's an x on the inside? Well, what that says is what number or numbers, should have made that plural, what numbers are 5 away from 0? Well, so if you think about it, like if you're at 0 and you walk out 5 to the right, for instance, 1, 2, 3, 4, 5, well, you'd be at 5, okay? What if you walked out 5 to the left? Well, if you walked out 5 to the left, 1, 2, 3, 4, 5. So what two numbers are 5 away from 0? Well, 5 and -5. But visually, what I want you to see here is this idea that we're coming at it from two different sides, right? 0's in the middle, and then you have the negatives on the left side, and then you have the positives from the right side. So if you don't see, for instance, if you look at, go back. So if you look at x here in the problem, the absolute value of 2x. So what I don't know is that what we're saying is there's some number that when you multiply it by 2 and add 4 is 16 away. So there's some number that's when all of that happens is 16 away from 0. Now we don't know if that's 16 from the right or 16 from the left. Right, so it could be 16 coming from this way, or it could be coming from that way. Because again, we said what numbers. Really, there's two answers here, right? So what I could say is I could say x equals 5, and x equals negative 5, right? Because both of those things are true. If I said who's 5 away from 0, well, 5 is 5 away from 0, but negative 5 is also 5 away from 0. So what we're saying with this problem then is we're saying, okay, well, who's 16 away from 0? Well, again, are you talking about 16 out to the right, or are you talking about 16 out to the left? Right? That's what we're kind of asking ourselves. Well, so since it can be coming from either direction, and we're actually not sure, then what we do is we actually have two different equations. So I'm going to pretend, or not necessarily pretend, but I'm going to think of it this way, say, okay, well, there could be a number that's coming from the left side, like where the negatives are, or there could be a number coming from the right side, which is where the positives are. Well, what I do with that is that the one that's coming from the positives, right, because you see the 16 is positive, what's going to happen is that that's going to stay exactly the same. So what I'm going to do is I'm actually kind of going to do this problem 2 times. I'm going to do it once, solving it just exactly as it is. I'm going to just copy it. That's why I say same. 2x plus 4 equals 16. 2x plus 4 equals 16. Actually, I want to do one little thing here. I'm going to put this in purple, since I'm doing my positive in purple here. So I want you to see that what's happening there is that the positive, okay, there's a positive 16. Now, what I'm going to do with the left side over here, because maybe that number is coming from the negative side, is that I'm going to change that. I'm going to write it as it is. So what's inside the absolute value stays exactly the same. So 2x plus 4 stays exactly the same. And the only thing that changes there is that that becomes a negative 16, right? Again, why is that happening that way? Because there's some number that's 16 when multiplied by 2 and added 4 to it that's 16 away from 0. So we just don't know if that's 16 from the right side where the positives are or 16 from the left side where the negatives are. And so what we do is we represent it coming from really kind of 2 different directions there. So I'm going to get out my highlighter here. I just want you to see what we're doing there, right? So that's a positive 16. Sad looking highlighter. Let me try that again. I don't think I like that one either. Oh, too far. All right, third time's the charm. Well, we're going to move on anyways. All right, so there's a positive 16, and then there's a negative 16, and then the positive 16. So I'm just wanting you to see that that's what was different, is that we took 16, kept it really the same, positive, and then changed it once as a negative. And then so I'm going to solve each one of those equations. We add or subtract first. There's no parentheses, so we don't have to worry about distributing. There's no like terms. Don't have to worry about that. It's just a little 2-step equation. So I come up with 2x equals negative 12. That says 2 times x. So hopefully by now we're feeling pretty good about that. We know that the opposite of multiplication is division. The signs are different, so that would give me a negative 6. Let me come over here to this other one. And again, note that what was on the inside of the absolute value, that 2x plus 4, I didn't change that at all. I didn't change that to a minus 4 or something like that. So that stays exactly the same, which is why I did that in the 2 different colors. So what was in yellow is what stays exactly the same. It was just the last number. That's the only number you change. All right, so those cancel each other out. So we get 2x equals 12. And then divide both sides by 2, and we get x equals 6. So there's, as we said from the very beginning, maybe this is numbers coming from 2 different sides. Maybe it's coming from the right side where the positives are. Maybe it's coming from the left side where the negatives are. So, and there's actually both answers are correct. Just like over here, we said, what number is 5 away from 0? Well, 5 or negative 5. So I know that's a little bit different, because in math, we're usually used to getting just one answer. So this is a little bit different where we're actually getting 2 answers. So we could actually say that, well, what's the value of x? Well, it could be a negative 6, or it could be a positive 6. So you actually have 2 answers there. All right, well, this is our last one. I know you're kind of sad coming to the end here, but let's pause it, see how you do number 9 in the middle, try number 9 on the right side, and then we'll check our answers for one last check in a second. All right, so our last break. So let's see how we did on number 9 in the middle. So for number 9 in the middle, should have got y equals negative 3 or y equals negative 1. And for number 9 on the right side, should have got z equals negative 5 or z equals 3. All right, well, we made it. here's the finish line, so we actually made it to the very end. Appreciate you watching the video, and please like or leave a comment. You know, if you felt like the video was helpful for you, please like the video. If you have something positive and nice and constructive to say, then leave a comment. Otherwise, check our other videos that will be coming up soon from Simple Math. So thank you again, and have a great day.